Welcome to the Crazy Wisdom Podcast. I've got Nizar Horti here, and he is the CEO of Pixel Robotics. Welcome to the show.
Nice to meet you.
So, what is a pixel?
A pixel. It's very interesting. In fact, it's a unit that we use on the screen. I mean, it's a unit of, you can say, something that could be visually visible for a person. So you can say like it's the atom of of the screen. So the most, I mean, the smallest part that you can see, and usually a pixel could be composed by red, green, or blue. You know,
Mm,
it can be combined to show you colors, etc. on your screen.
mm. And I was recently, I had the same question like, what is that for? I think we talked about this in our initial call as well. Is that I had this question as of like, what is that for the human eye? And like whether it is the right analogy or metaphor. But before we go into that, why Pixel Robotics? What about a pixel is related to robotics?
The idea is the two parts are about the digital world. I mean, a pixel it means that we want to have some idea about the perception part, because it's not like straightforward for usual people to think about robotic about the perception part. So pixel is
Mm.
about all the perception, and robotics about all the action that you can do with the system.
Oh, interesting. So, okay, great. So it's that's the connection. So it's the sort of perception, the digital part, the part where the robot has to meet reality as and we just have tons of evolutionary understandings of how to meet reality every day and we don't think about it. And this is the big thing with robotics, right? Is like how do we actually build that into digital software, right?
And it's a big simplification, I can say, a quantization, because a pixel it's something that is not a continuum. So you have like it's very important for a numerical system. It's very difficult, you know. It's more analogic system that could be, I mean, continuous. So for a numerical system, you need to have something digital. So it means that it's quantified. So it's very important to have this approach to have a tractable system.
A tractable system. That is okay. That's really interesting. And you mentioned a few other words, quantization, which of course I've heard a lot in the LLMs as well. So basically, there's just this entire giant world out there, and philosophically, this is the most interesting part for me because it brings into the whole nature of science and history and philosophy. Just like we had all these cosmological theories on the nature of reality, and they were all blown away by by science, and now we're left in the wreckage of that, and now we're giving robots it. What have you learned in this world?
So you mean what you want that I explain a little bit this relation? So for me,
Sure.
yeah, for me the point is I think it's a very deep question to understand in which way we are processing in
Mm.
how to say continuous way. So the difference could be that we are more perhaps, I mean, an analogic system in terms of
Oh,
even
interesting.
perception and ever compute. So it's very interesting because today we use numerical system to do it, but perhaps it's not exactly the way we are doing it with our different sensor in human, and also with
Interesting.
your
Interesting.
computation. So it means that also some property are different. Um, but we can say also, because it's a very some nuance, that we, you know, when a neuron is firing, you know,
Mm.
it's firing or not firing. It's kind of
Mm.
can say
Mm.
continuity. We can see it as
Oh,
something that is
interesting.
not totally continuous. So perhaps this can encode a type of discontinuity, and also a type of digitalization. So perhaps it helps us to have something more compact. And also, also what we have in perception is we have a lot of how to say threshold to not perceive everything, of course.
Yeah,
Yeah.
interesting.
And also we have some law that have often there law of logarithmic
Uh,
laws that allow to compress the signal. So it's continuous, but it's compressed.
wow.
So this way you can see very subtle signal, and also when the signal is on the roof, you can still perceive something. So a lot of
Okay.
what we do today are related to this type of law. And I don't know if you know, but recently there is an introduction because there is some layer in deep learning that were very important. Are um, normalization layers, and some people show that you can approach this kind of layer with a sigmoid layer
Hmm.
that are, as I said, something that we have. It's close to logarithmic laws,
Mm.
so it's yeah, and it's very efficient. So can I think there is still many things to explore in this direction.
And what does that unlock? What does that unlock for you guys or for general the robotics community that it's a sigmoid layer instead of a logarithmic layer?
Oh, it's because the point is it's not it's easy to, for instance, you can combine it with other layer. You can have some property like fusion of layer, and you can have
Whoa.
like some good property for learning that are more difficult to obtain from normalization. Yeah.
Got it. Interesting. And so the normalization part is basically this part where that's what we're doing as human beings all the time to take in this giant amount of sensory information. Is that normalization that we're doing inside the brain?
I think it's if we are doing something similar, it's perhaps more like, as I said, sigmoid law, something like this. The idea is to not have like nothing go to the roof. You don't have like one signal that will dominate everything, and so it will be very hard for you to learn something in this case.
Oh, that brings to mind all of this stuff I'm just a very beginner in terms of local minima, right? Where it's like where the LLMs they got trapped in a local minima, and then something about the transformer allowed us to get out of that local minima. Is that right?
It's more the method of learning that is important in this case. A local minima, you have to see it like you can see it's easy to see it in 3D. You have like a region of learning. This region, you need to for your algorithm need to find the minimum of this region. When you find the minimum of this region, it means that it's where your loss is the minimum. So usually you try to translate your problem in terms of loss. It means that
And
you
what
have
kind of
to find
loss?
a way to write it mathematically. And when you get a very low loss, it means that you have the good solution. And
Interesting.
so you see like you have like a function that represents the loss, yeah. And the point is sometimes you have some low part, but it's not the global minimum, so it's not the best region. So you have different algorithm. Sometimes you can start from another place, or you have different strategy to not be stuck in the local minimum of the some local minimums, but to find the global minimum. Yeah.
A global minimum. Interesting. And how important is all the stuff we just discussed? Because that's very important for large language models. How important is that? Are these same problems in the robotics world that you guys are dealing with?
Everywhere,
Totally different
everywhere. In
everywhere.
fact, what
Okay.
is interesting with learning, and also the transformers push in this direction more.
Uh-huh, uh-huh.
Uh, Globally, you have like when you speak about loss, you can have loss everywhere. Many problem can be
Yeah, interesting.
described with the loss. So this kind of problem is very fundamental. It can touch every discipline. And what is very good with transformers, it's also another novelty. I mean, about transformers, it's for instance, before, for instance, when we were working on voice, when we were
Yeah,
working on image, or when
yeah.
we were working on text, it was sometimes different approach. I mean, and
Mm,
particularly with text. So the NLP, I mean, the NLP researcher were working on some type of algorithm, uh, so natural language processing, and the people were working on, for instance, computer vision, or even voice. I mean,
Hmm.
computing of voice analysis. We are using totally different type of approach. And what was very good with transformers is we obtain a kind of unification of
Wow.
representation of data. It is the big strength, and it's one of the reasons it unlock multimodality. Yeah.
Eh, Okay, that's so interesting because that kind of does a revisionist history for me on the entrance of the transformer into this world. Because basically, what I got from what you just said is from 2015, when the transformer was sort of like brought into existence, a lot of work done by OpenAI, a lot of done by University of Toronto. They basically created this initial version that takes large language corpuses and translates those into numbers, translates them into math, and then gives us this ability to predict text out of them. Now that was 2015. We're now in 2026, and so really starting in like 21 and 22, that's when all of a sudden the commercial interest started to bring in, and we all of a sudden we got ChatGPT. And from what I got, what you just said is that once that commercial interest came in, then you had a whole bunch of people really incentivized to create a multimodal solution that would allow it for text, for images, for voice, for vision, and put it all into one thing. And now it feels like we're entering into a stage like right now where the large language model thing is interesting, really important. No, like it's hard to discount that. It's even hard to say that we might be in a bubble because 2 or 3 years ago people are saying we're in a bubble, but it just doesn't slow down. I do think that we're at the end of the internet training. I do think we have run out of large language corpuses, but we have tons of code, and then we have synthetic data. I would love to talk about synthetic data later, but basically we're at this point now where the large language model, we know what it is. And a lot of people are saying that, including myself and my dad on our show Stewart Squared, are basically both agree that the world model is seems to be like that's going to be the big thing. But all the world model is just in sort of R&D. And Ami Labs by Jan LeCun, they've been very explicit in saying this is R&D still. Like we're not here at the world model. The world model is going to be really important. And so this unification of representation data with the multimodal stuff, does that get baked into the world model itself and used as a primitive or a standard, or do we need a new standard for world models?
So usually when people are speaking about world model, it's more like a model that are like predictive of what will happen next, but
Oh,
I mean on a physical base. I mean, for instance, many work were done with, for instance, videos to say, okay, we have
yeah, interesting.
this part of the video we can predict. So we want to learn what will be a kind of gradient of change of this scene to the
Wow.
next phase. Yeah.
Whoa.
So mainly people, uh, when they speak about world model, is this after you can enlarge the scope of this and say, okay, because in fact, for me, there is different way to be more physical. I mean, and word model could be one, but in fact, there is many
Whoa.
ways to do
Okay.
it. And word model is a kind of methodology also of
Interesting.
how you teach your system to find what will happen next. But more generally, I think it's very interesting to understand the capabilities of transformers and the fact that I think only few people understand that they help us to abstract a representation. And
Mm,
before, I don't know papers where you can like abstract in this way text and in a way, and for instance, image in another way. And
yeah.
you have a famous work on that called Clip from OpenAI, with uh, contrastive learning. They they show that you can have a kind of uh, I mean, a common representation. We can say latent. We call it latent usually. So you can have a latent that is the same representation from two modalities. So it
Whoa.
means that you have a transformer that change the representation in a way. You have uh, an image that will also use transformer to change the representation of image. And after you try to learn how to have a common representation,
Whoa.
a common latent that we learn with a contrastive method to have a common, you can say a common language, more or less. You see
Wow.
the point? And
So,
after this could be used for many modalities. It is one of the strengths of the transformer is the ability.
huh.
Also, I wanted to say something about what
Yeah.
you said. It was very important and interesting. When you speak about transformer, you say, okay, perhaps, I mean, all the text of internet are already used. So what you can do? For me, transformers is very interesting, but I see it a little bit like a brute force, brute force learning.
Yeah. Okay. Interesting.
So I think we have a lot of, I mean, we will have a lot of enhancement, new theory, new algorithm that will do better with fewer text.
Yeah.
With a
Yeah.
smaller text, you can learn far better. I'm sure of it. That there is room for improvement, and one of the reasons I'm sure it's because I mean in the last year I think we it was exhausted. I mean the new data were exhausted, but we still have a lot of improvement in the new models every every 2 months. We have
Mm,
innovation coming from
mm.
everywhere in the so so this game is not finished at all. I think it's only the first stone to have a good LLM, and it will improve a lot in different way. Yeah.
Which is getting me. I like to retain skepticism at the same time as sort of a belief in things that are possible. And so many people are on the line of whether this is sort of a hard takeoff or whether this is a slow takeoff in terms of AI, and whether we're really at the point at which most of human life gets transformed pretty drastically, or if it's just a sort of red herring or a fake out. Really interesting stuff. There's a lot I wanted to talk about there, but there's so much that I'm trying to. So I've been trying to figure out small models, and the small models are really interesting. And I just did some research this morning on the small models in the sense that they're getting really small. They're really helpful for doing well-defined tasks like classification of text, classification of categories. But in general, I know that LLMs are bad at classification and categorization. Like if you're talking with a chatbot, it'll do a lot of good classification, but it'll also get a lot of things wrong. And me, as the human being, always needs to come in, and I cannot leave it to classify things in an unbounded way. I can allow it to classify things in a bounded way, and I'm working on sort of structures to do that. And so the small models are really interesting because they can do a lot of things, and they're going to get really small. Was that what you were talking about with new algorithms that no, that you were talking about like new competitors to the transformers that are not brute force, that aren't these sort of bitter lesson Sutton guy, like just throw as much compute as possible. You're talking about different algorithms that are not large language models. That's what you said, right?
Different algorithms that are not transformer. It could be large language model. You can still call it like this, large
Wow.
language, but
Interesting.
perhaps not based solely. I mean, for instance, on attention, the way we see it. For instance, attention, the basic attention is, as I said, brute force. You take a word and you
Yeah. Okay.
try to correlate with a big context. But after, you can have attention that is modified, that is more focused on some part. So many people are working. There's a lot of strategy, different strategy on this. So how to not have like a brute force attention, but attention based on something that is more relevant. So so I think this will have a big impact, because one of the problem of attention is, the law is quadratic. It means that you have a square. You have to put in square about. The memory is related to the square of the data for the to say for the 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 attention part.
Uh-huh.
So I think there is a lot of stuff in this way. Also, I believe that there is a lot also that could be related to true true relation between entities, something like this.
Mm.
So yeah.
Oh,
So
that's interesting.
so I mean, there's a lot of people that are working on knowledge graph,
Yeah.
all
Okay.
this
Yeah.
stuff.
Yeah. Yeah.
So I think there is some study that are emerging, but there is some relation possible and some improvement that can come from there. So I think there is a lot of strategy that are, still possible and not explored today. So
Yeah.
I believe that what you said about small model, what I like is what I think about the future. It's a little bit was what people are doing. So the first approach is mixture of expert.
Yeah.
I don't know if you know
Yeah.
this one.
Yeah.
So the idea is you have a big network, but only few weight are used during inference for each time. So
Mm.
it's allowed to not use too much memory during the inference. But I believe really that it could be also another approach is to have like small model, very specialized, and to have a bunch of this kind of small model
Mm.
that can that
Mm.
can have like can be related to an agent, for instance. It could make sense. And to we don't need to have like a big network that can speak in Japanese, in French, in English, and knowing
Yeah.
about
Interesting.
medicine
Yeah.
and
Yeah. Yeah.
mathematics in the same time. Why we
Why are we
need
doing
this
that? It's
kind?
very wasteful. It's very wasteful, right?
Yeah, at a given point, we need only. I need something in math, so I need an expert in math. I don't need someone that is knowing everything.
Yeah. Interesting.
So you can imagine that have something that in small block, very specialized. Of course, we know that when the system learn different stuff, he is clever. That if you give
Yeah.
him
Interesting.
only mathematical books, so you can have like a general, I can say general cognitive abilities, and
Uh-huh.
after a specialty on one topic, something like this.
And this is all like a model of experts architecture that you're talking about, where you have one ability inside the model of expert, one general cognitive ability that can make the connections across disparate disciplines by having all of this different stuff. And then you have a bunch of small models that are focused, that it goes out and goes
Yeah,
and does its thing to get more specialized. And I want to get more into the world model stuff. But before going in there, I want to talk about, and this might relate, which is that we have stochastic, probabilistic large language models. These things are probabilistic in a similar, we human beings are also probabilistic, stochastic in a lot of ways. And then we have determinism and deterministic software. We have software that you put in an input, you get an output, and that's more or less, you know what bugs are going to happen. You have bugs, but it's not like probabilistic bugs. And these two things, most people think of them as contradictory, but everybody right now is combining them, including me. I'm like, in order to build the software that we actually recorded this thing on, I'm having to harness the deterministic capabilities, and I've been doing so much of this over the past few days. It's so much fun because I had no idea what I was getting into when building this software. And it turns out that I need to do a pipeline for each of the episodes that I record, which is, so you're on a browser, you're on Linux, I'm on Chrome, I'm on a Mac, all the different browsers, all the different capabilities of data files. And I didn't realize it at the time, but I reverse engineered Riverside, and Riverside, because they serve millions of people, they standardized on one thing. So they say you can only record on Chrome. I said, you know what? I'm going to record on everything. I want this to be as I can do it because I'm not trying to serve 100 million people. So I'm only trying to serve myself, and
yeah,
I'm, just creating like a pipeline that can just do wasteful stuff because I'm just got my own deterministic stuff. And so I'm building this deterministic layer where it takes in the episode, merges the episode, and there's just so many pieces inside of that. And so I'm using probabilistic things to help me build the software, which is deterministic. And then later on, once I have a good understanding of that deterministic, I'm going to bring the probabilistic layers into it, build the small models, do all these things that allow me to do both. Now, yeah, go
It's
for it.
interesting what you said because there is a new trend that show that, for instance, some model could be more accurate if you don't put an orchestrator, but if
Oh.
you put a kind of graph of the different task and of the
Oh,
behavior. So you explicitly write the I mean this kind of graph or this kind of explanation of the detail of what has to be done. And usually it's more perform. You have a better performance compared to have an orchestrator that has to decide what to do all the time. Yeah.
brilliant. That's going to help. So I need to build a graph of invariance. What I got from you
Yeah.
said invariance is something that keeps on the LLM keeps on
Yeah.
telling me to do
And
is
it's
that.
sent.
Yeah.
You send it. Uh, in your message to the AI, you send it directly. You don't use it in the agentic way. Yeah.
What do
So
you mean by that?
directly, it is inside the prompt of the yeah. It's
Yeah. Okay.
directly in the prompt. Yeah.
Okay. In the prompt to say that. Okay.
Yeah.
Now let's go back into world models
Yeah.
because I'm still not clear on, does the world model replace the transformer or is it just something outside that doesn't really relate to the transformer?
It's not replaced. In fact, it's the way you. In fact, it's more about the loss and the way you are doing your learning and the objective of your learning.
The objective of your learning. Got it. So what you're saying about, most of the world models right now are people predicting what's going to happen in the next frame of the video
Mhm.
or in the sort of physics model.
Yeah,
And so that's what you're trying to do is predict those things. Is that right?
yeah. So, for instance, it could be to the way you predict how the pixel will move in your image. Like
Oh,
you will have a kind of flow, yeah, and you will try to learn this kind of flow, for instance, and you have a loss that is related to that. Yeah.
oh man. Okay. So it's learning about the future in physical world, learning about, but and the LLM is totally outside of that because the LLM can take multimodal inputs and outputs and everything like that. And there are diffusion models because I know Sora was based on a diffusion. Is a diffusion model a world model?
No, in
Uh,
fact, the diffusion. In fact, in the diffusion, for instance, what you are doing is it depends. So
uh-huh.
imagine we speak about image, for instance. The diffusion model is you have like the input will be a noise, a noise, noise system,
Uh-huh.
noise image, for instance,
Yeah.
a noise image, and you learn what is the transformation you will do to
Yeah.
have a denoise image. Yeah.
And then and that creates this beautiful Sora image because you have a bunch of noise, and then you convert that into actually something that humans can find a pattern in. Did I get that right?
The fact is, the point is, you have like okay. So for a diffusion model, the idea is you have a noise image, you learn to denoise. So
Uh-huh.
it's the first
Yeah.
idea.
Okay.
But if you do it repeatedly, so it seems that you can start from noise, total noise,
Yeah.
and you can denoise it to have your image. But what you can do is to have a bias. So it means that you have another signal, for instance, text, that will say to you to your system, oh, the noise you are observing, in fact, it's a cat.
Oh,
So
interesting.
it means that the denoiser is biased by the input signal. Yeah.
Interesting. Okay, yeah, and this gets into bias and how to basically use bias in this way that essentially gets us what we want uh, because you bias the model. Man, it goes back to philosophy here too as well. I've been doing a lot of research or I've been listening to John Vervaeke. John Vervaeke is a great cognitive scientist at the University of Toronto who was doing all of his work as the University of Toronto was helping with the transformer model and the large language models. And so he had a sort of like a view into this whole world as it was developing. And I was just listening today about the philosophy world of civilization and the romantics as they were talking, and they're like, oh, our minds are a blank slate. Our minds are just a blank slate where we just kind of have all this stuff coming in, and it's like, changing us and everything like that. And then the opposite is the mind is fixed, and then the world is a blank slate. And it's neither of those things. It's neither subjective nor objective. It's transjective. I am having
Yeah,
yeah, go for it. Mm-hmm.
and we can say also that if we say this, if we have to say something about like the biology, we can say
Mm.
that our mind is a bias based on our perception. I mean, of
Oh, interesting.
bias related to our sensor, you know, because you have vision. This vision will change your brain to have some
Yeah,
property. You have
yeah,
touch. You have,
yeah.
and also you can observe the world only based on this. So all of this will create a kind of model that will bias a lot about what you can expect about what is outside. Yeah.
So yeah, and it gets into expectation. So we have perception and we have expectation, because what you're talking about with the world models is that that's what we're doing, and the work of Carl Friston is also related. Although I don't understand the work of Carl Friston, but it's something about prediction where we're trying to predict the next state. So we're trying. Yeah, go for it.
For instance, if you have the law of physics, like the simple one is gravity,
Mm.
you know that if you have an apple
Yeah.
in your hand and you release it, and you know what will happen, and more or less the velocity of the apple that will go to the floor and perhaps roll a little bit on your floor. And all of this is something that you have seen many times.
Mm.
So you expect this
Yeah.
kind of this kind of event. So it's important. I think what I don't like, I will be honest with you, is people that try to make an opposition between, I can say physical model and also LLM. I mean,
Mm.
I understand that, for instance, for how to say, for advertisement, it's nice to say LLM are wrong and there is a new method that is totally the best, and we have to, to remove the other one, etc. But in fact, it's two kind of approach. I mean, that are for me complementary, of course, because I mean, the way LLM are done today are very efficient. Um, there is one way it's not efficient. I can discuss with you about it if you're interested. But I believe in the future it will
Yeah.
be an evolution of LLM in this direction. For
Wow.
instance, it's not working well. Perhaps I can tell you now if you
Sure. Yeah.
interested.
Yeah.
Okay, so there is another branch of LLM that are diffusion LLM.
Uh,
So the reason is, for instance, when you are doing you are working with an LLM, there is a prediction of the next word, next
hmm
word, next word, next word. But what can happen is you are predicting the next word, but when you are continuing, what you've done before is, it's finished. It's already
Oh,
here. You cannot modify it,
wow, interesting.
you know. So you have to do many turn and after correct. So in diffusion LLM, the point is, in fact, you are changing all the output. So you can, at each step, exactly like what I said with vision,
Uh,
you have an image with blur and with noise, and you have an enhancement and an enhancement, and you have like this approach that I believe very promising is to have this output that will change. With the different step. So it could be a little bit slow compared to the LLM that we see
oh,
today.
interesting.
But the final answer can be very accurate, very nice, because it's an holistic approach. It's not only next word approach, you know.
I've got to find people to interview about what you said,
Okay.
because that seems important, and it also seems relevant to how do we get real time things, real time systems that are not taking 100 or not taking a minute to 2 minutes or 30 seconds, like just 30 seconds to get a response, basically. How do we do
Yeah.
real time? And they're getting closer and closer with this for things you don't need to search for, with all like that'll give you an answer immediately, including with Cerebrus and all of these sort of like, I think it was there's a term for the hardware that's being built to do these. Now, what you just said about the diffusion model seems really important, but may take longer. And it, like, so I'm gonna find people. So who, no, how close are we to real time? Because for robotics, we need real time, right? Like, what's going on with real time?
Yeah, it's very important, and I have I mean, I'm developing a work with a PhD related with really focus on this on real time. So the subject is very huge. So I'm focused on vision transformers. It's
Okay.
only it's an application of transformers, but for vision. Why also I prefer to use vision transformers is simply because of the resources to train and to test ideas. If you do it with LLM, it's huge. So you need
Yeah,
very
interesting.
big cluster of, yeah. So the resources are so big. So with VIT, it's more easy to test new idea. And the idea is that even for VIT, so it's difficult. You have 2 points for robotics, especially for robotics. Is the compute time is very important. So you need to have like something that react very quickly. So for instance, if you are doing robotic, I mean, for a car or even for a robot, and your goal is to avoid to hurt people, you cannot react 2 or 3 seconds
Yeah,
after.
yeah,
So
yeah, yeah,
you
yeah.
need to
Interesting.
do it in few milliseconds. And the second part that is very hard is about the memory footprint,
Oh,
because
interesting.
if it's too huge, I mean, you need, some hardware that is not affordable. I mean,
Yeah,
that you
interesting.
cannot have in a simple robot. So it also the cost is very high. So you need, I mean, to have a model that is also small. So we are working on this. So we work on, and I hope I can after. What is interesting also with what we are doing is sometimes you can have ideas that are working in vision, and after we can explore it in LLM, and the contrary also. For instance, we were inspired by some idea of LLM that were that are very clever, and also because it's a very dynamic I mean topic today. Many teams are working on LLM and try to improve the speed, etc. So we borrow some ideas, and we now have a very good system that we want to publish soon. I hope in few months. That where we have a very small model with also it's important good accuracy and a good
Hmm.
speed. So the point
Hmm.
is also, of course, if you have something very quick but a very bad accuracy, no one is interested, of course. So you need to be good on all these metrics, and we succeed to have a good one. And we I
Yeah.
mean, it's interesting to push on it, because for me, I'm always interested in practical,
Yeah.
not only theoretical but
Yeah.
practical stuff. I mean, if we have a very good stuff in lab, but it's only for lab, or if it's, I mean, the cost is, I mean, I don't know, 20K to be able to use it, it means that no one will use it in the future. So I'm very interested also to have like practical stuff. So tomorrow, when I come with a good algorithm, I know that I can do it in real time, something like this.
Very cool. And this feels related to, we can go into what Pixel is doing. What are you guys doing at Pixel?
So in so yeah, to remind you, I work at Pixel, and also I have a position in the university. So what I just mentioned is something I'm doing in university. So at Pixel, we are working with different company. So we work in the past with automotive company, also with L'Oréal. So and also with a smaller company that are working on 3D in real time 3D. So
Cool.
one of the focus is really to be very good in real time 3D. So high quality and I mean simplification also. We started doing specialized sensor, etc., but we consider that it was not the good path. So today we are working to have system that can work on a simple smartphone. So the difficulty is more on the algorithm than on the hardware. So everyone can use its own smartphone, film something. It could be uh, his apartment, it could be an object, and after I we are able to have a mesh coming
Mm.
from it. So I think it's very interesting application, and more specifically also for L'Oreal, we develop a system to be able to control, robotic arm, industrial robotic arm. So the idea was to be able to have a representation in 3D of the environment, and after to have a robotic arm that can do many tasks. And we develop a simulator, something to simulate what the arm is doing in the environment. And when I mean, there is a validation of what the arm is doing, you can simply use the same device to launch the real robot doing the stuff. Yeah.
Okay, this is very exciting because this is getting into stuff that I am working on and teaching people right now. This is the ESP32 for those who are watching, and then I just taught people how to connect the servo motor, a little tiny servo motor, into the ESP32,
Yeah.
and it's really fun because I'm just like what you said about the robotic arm, and we could get into humanoid robots. And I know that your specialty is in haptic. And for the listeners who don't understand, haptic is like the touch, the felt sense of all these different things. And like, I imagine that you're doing that for robots. And if you want to share anything, let me know. You can interrupt me at any time. So we're gonna basically I'm getting into building robots. You know, the things I just showed you, they're just kind of cheap, but it allows me, and like I'm not expecting to do much with them. But I'm trying to learn as fast as possible because I think robots are going to become so important, and it's all just really interesting to work in this. And so the sensor that you guys started off with, these specialized sensors, and then you moved over to making a mesh and a simulation of an industrial robotic arm. And we could talk about a bunch of different stuff because I know simulations are important. I want to start getting more into simulations for the same reason I was talking about these guys. Is just like, what does it mean to simulate stuff? Uh, I'm curious, what does a mesh do for you? Is it like is it a world model? Is it like is it related to what like Marble is doing with World Labs? I think that's what they're called. I also recently learned about photogrammetry and point clouds
Yeah.
and all these different things. What's going on with all those things?
Yeah. So in fact, in 3D, you can have different type of representation. So one representation could be voxel. If you know voxel, it's kind of a pixel, but in 3D. So you have
Oh,
cube
interesting.
of
Oh, interesting.
presence of object in a space. You have like another one is a pixel. It's pixel. Sorry, excuse me, excuse me. Point
Uh
cloud. Sorry,
huh.
point cloud. Point cloud are simply point that are in an environment that represent, I mean, a simple point, but it could be a colored point cloud, and perhaps it could be also you can have like the normal, some property like this. You have a new representation called splatting. That is also another popular representation, and you have the representation that is a mesh. The mesh is a representation that is used a lot in video games because it's a very, I mean, easy to use, very handy representation. It's
Interesting.
usually you have different type, of course, but the most usual one is you have triangle that represents the surface of the object. So the surface is usually you want a watertight surface composed of triangles. Okay,
Huh.
and yeah, and after it's easy when you have it to manipulate, to make a lot of compute, to make the rendering. For instance, your 3D render are optimized to render meshes. So yeah, and the point is at the beginning, as I said, we developed special tools. In fact, we had like a system that were rotating in the
Huh.
room, and we had I mean, a procedure to scan a room, etc. And the point
Huh.
was it was hard to develop the hardware, all this stuff. We had
Yep.
also a kind of box where you put an object inside. Something was turning inside the box, and after it was you can have a scan of the object.
Uh-huh.
And at some point, I believe that it was too complex.
Hmm.
It was too physical. Also, if you want to interact with customer, it means that you have to move their place, or they have to give you the object. So many difficulties.
Oh,
So,
interesting.
so at the end, I realized, okay, stop. The best is to simply use a smartphone, so everyone
Yeah,
can
interesting.
can,
Yep.
can
Yep.
use and to focus. To have it's not easy, but to focus to have a very good software that can interpret what the smartphone has taken. Yeah.
Oh, interesting. Uh, I have a friend who is currently in Europe right now. He's currently in Portugal, and he is a 3D artist
Okay.
who creates tons of stuff. And so I'm very interested from what he shares with me about all these crazy things. And I remember 2 or 3 years ago, he constantly builds these 3D worlds. And he like we do a lot of stuff at the AI Whisperers Club in Buenos Aires, where he shows us these 3D worlds and explains what's going on and teaches us how to vibe code these things. Now, and so he's got these 3D worlds, and I remember he could take it was probably similar where you could just take a photo of something in the real world and then get a 3D image inside of the 3D world that he
Yeah.
created. And so, but you guys are doing it for like a companies like L'Oreal to basically figure out their robotics, industrial automation type of thing, basically, right?
Yeah, it's important to have this kind of stuff to have, like, if you want to, for instance, to have a robot that will do some stuff, it's important to have to know what is around. If you want, for instance, to have like simulation or this kind of stuff,
Mm.
so this kind of tool can be useful. Yeah.
So, and we'll take another like 10 minutes or so. The simulation. Let's go into simulation because as I was just talking about with my friend who's creating 3D worlds. We have video games. We have tons of people who've created really interesting, creative video games, which are simulations, which have work involved, and people do work for free so that they can play
Yeah.
and do all these things. And now we're getting to the point where we can just build crazy simulations
Mm.
with all these tools. And it feels like we'll go take it back to the world models because you were talking about world models are predictive. So we need the world model to predict what's going to happen in a scene, in a 3D scene, whether it's a video game or it's like a 3D meeting room. Because I was in Silicon Valley for a long time, and they're always trying to build these 3D Second Life where you go and meet in these 3D worlds. That feels like it's now kind of unlocked. It also relates to Meta's vision of that. Now, how are the robots and the digital parts of the robots, the software that you mentioned, how are we going to end up in this? What's like going to happen over the next 5 to 10 years? I'm not asking you to predict the future. If you want to try to predict the future, feel
I
free.
can.
Yeah. Okay. Yeah. 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 So
It's not difficult. It's
Yeah.
not difficult.
Yeah. Yeah. Where are we headed with this?
No, it's not difficult. In fact, it seems to be. I will not be Nostradamus today, but
Yeah.
it's not very difficult. The point is, we have like good agent in terms of I mean, cognitive aspects, language, etc. And simply, the next step will be to have like a more physical agent. I mean, something that will and where you will have a kind of how to say cooperation. But if we want to be very simple, sometimes I say it to even to children, you can say that
Mm,
AI could be the brain and the robotic is the body, more or
yeah.
less.
Yeah.
So the point is, we need today algorithms that are not only algorithms that can speak, but algorithms that will react to what you have around you. So the observation,
Yeah.
and to be able to I mean, if you speak about the loop, the perception action loop, to be able to use this perception action loop. So I think the future is, I mean, the very close future, and still there is already some research that are very good on this topic. So, for instance, if you speak about VLA, so VLA is I mean, big model when you have like the vision to observe something, and after there's a coupling to the action,
Hmm.
so the action of the robot. So we are going in this trend. So to use the power of AI to be able to have like a robot that can move, that can also do a real task. And what I'm developing, what I'm working on today is to unlock the possibility of robot to do, I mean, real task, not only to
Wow.
be like
Oh, interesting.
I mean, a toy that's dancing, and many with many robots you see that, but to have like real interaction. And when I started my journey to be a researcher on this topic, it was about how to bring perception to robots, and it was really my topic. So I think it's not totally solved, and it's still very interesting, yeah, to have this type of, because today we can say, I will not say, I don't like people that say like this, but I mean, motion of robot, it's not solved, but we know how to have
Interesting.
a robot moving. We also, Chinese are very good to cut the cost. So
Yeah. Yeah.
we have not very expensive robot today that that are doing
Yeah.
very impressive stuff. So you see, we don't have a problem of mobility, or yeah. So for me, the issue is more about closing the loop of perception action and
Mm.
multimodality, of course.
Okay, that's really good. That helps me a lot. Kind of ground what I want to teach people with these robotics courses. If you were to say one thing that I should start learning to start helping people focus on this perception to action loop. Well, okay, so I already got action. So
Yeah,
I connect this to this.
I will tell you
Yeah.
directly, very simple. So I can say, if you have a camera,
Yeah.
like a Arduino camera,
Yeah. Okay. Oh, cameras. Of course, I got to get cameras.
you
Yes,
put
that's
it
it.
on the servo,
Yeah.
the servo motor,
Yeah.
so you can control the motion like this,
Yeah.
and you simply move a ball, a red ball,
Okay.
and you say, so your goal is, your program is, put the red ball at the center of the camera. So
Okay. Yeah. Yeah.
it's very
Perfect.
simple. And after, when you move the ball, so the camera, for instance, you put the pan movement, panoramic
Yeah.
movement at this angle, and the camera will move when you move the ball like
Yeah.
this.
Oh,
Camera will follow, and
brilliant.
this is perception. So most simple,
Yep.
not with AI, of course, but to start, it's
Yep.
very nice to start uh, perception action.
Brilliant. That's amazing. So, what are the next steps for Pixel? What are you guys trying to do? What are you most excited about?
I mean, for us, as I said, the best is to be able to have like it seems to be solved, but it's not solved. To have like a good mesh of your environment, of what you are doing. There is a lot of application. It could be for advertisement. It could be to have a virtual showroom. There is a lot of application. In fact, it could be for video game, as you mentioned before, even for cinema, but to have a very accessible and simple device to be able to do that. For a long time, for big studio, big company, also, it was a lot of time of artists to make a mesh, or a lot of how to say, setup with lighting, with many things to be able to have a very accurate scan. So if you can have a very good quality without spending a lot of money, so in fact, as I said, the intelligence will be on the algorithm. and it thinks that it means that you unlock it for many people, so you don't need to be
Ah, yeah,
very
brilliant.
rich to start. And yeah, it could be when you see, for instance, in terms of quantity, of course, you have a lot of video if you open YouTube,
Hmm.
but you have few 3D models, because a
Yeah,
lot of 3D models are coming from artists, for instance. And it's one of the reasons it's not so easy, for instance, to train a model. The training part is not easy because of the quantity of data we have access to. So also this kind of tool can help in the future to create more database of objects, and so to have a better training in the future.
yeah, brilliant. Okay. Well, go check out Pixel, everyone. Thank you so much for coming on the show, Nizar.
No problem. It was my pleasure.